Ohm's law in the circuit. The electricity is a type of energy that is created by the movement of electrons between 2 points with a potential difference. This movement of electrons, electric charges, is called electric current. Electric current flows through a system called a circuit. The simplest circuit is a no-load circuit containing a power source and conductor. A circuit is a closed path through which current flows in a loop and returns to its source. For current to flow, the following conditions must be met. The current path must be continuous, closed loop. There must be a potential difference between the starting point and the return point. A conductor is a material that allows current to flow easily. This type of no-load circuit is called a short circuit, in which current flows until one of the two components is damaged, which occurs in a very short time. A normal circuit is a circuit with a load that allows current to flow to do work and includes power source, conductors, and a load. If the circuit is open at any point, there is a potential difference between the points but no current flows. When the circuit is closed, electric current begins to flow from a higher potential to a lower potential through the load and returns to the power source. The most important parameters describing the circuit: current, I, the amount of electric charge flowing through a circuit. The amount of current is measured in amperes, A. Voltage, V, the electrical potential difference between 2 points in the circuit that allows current to flow. Voltage is measured in volts, V. Resistance, R, the opposition to the flow of current through a material or other component. The resistance is expressed in ohms, omega. Power, P, the amount of work done by electricity, consumed or delivered in the circuit. Power is measured in watts, W. Electrical circuit with multiple branches and loads. The electrical circuit is described by Ohm's and the Kirchhoff's laws. Ohm's law. I equals V over R. Current flowing through the conductor across 2 points is directly proportional to the voltage and inversely proportional to the resistance of the conductor where it flows. The value of the current flowing between 2 points of a circuit depends on the potential difference between these 2 points and the resistance of the material through which it flows, which results from Ohm's law. For the same, constant resistance, when the potential difference between 2 points of the circuit increases, more current can flow because the higher potential pushes the current with greater force, and the resistance between the 2 points can be overcome more easily. As the potential difference between 2 points in a circuit increases to a point where it reaches a critical value, for the maximum current flow through the resistance, the current not encountering sufficient resistance begins to increase rapidly, generating heat that damages the circuit and causes it to break. From Ohm's law, I equals V over R. If V, volts, increases to the critical point infinity with constant R, resistance, I, current, also tends to infinity. Example: 1 ampere equals 1 volt divided by 1 ohm. The resistance is constant 1 ohm. And voltage increases from 1/10 of a volt to 10 volts and to 100 volts. The current is 1/10 of an ampere for 1/10 of a volt, 10 amps for 10 volts, 100 amps for 100 volts. When the resistance is constant 100 ohms and voltage increases from 1/10 of a volt to 10 volts and to 100 volts, the current is 1/1000th of an ampere for 1/10 of a volt, 1/10 of an ampere for 10 volts, 1 ampere for 100 volts. As the potential between 2 points in a circuit decreases, the force pushing the current to flow decreases, and the current also decreases until it stops flowing. If there is no potential difference, when the potential difference between 2 points in a circuit is constant, but the resistance between them increases, the current flow will become less and less because the force is too weak to push the current out and overcome the increasing resistance. If the resistance increases to a value at which current is near zero, the circuit between the 2 points becomes like an open path for that current. If resistance increases to the critical point infinity with constant volts, the current tends to zero. Example: 1 ampere equals 1 volt divided by 1 ohm. The voltage is constant 1 volt, and resistance increases from 1/10 of an ohm to 10 ohms and to 100 ohms. The current is 10 amps for 1/10 of an ohm, 1/10 of ampere for 10 ohms, 1/100th of an ampere for 100 ohms. The voltage is constant 100 volts, and resistance increases from 1/10 of an ohm to 10 ohms and to 100 ohms. The current is 1000 amps for 1/10 of an ohm, 10 amps for 10 ohms, 1 ampere for 100 ohms. As the resistance decreases between 2 points in a circuit to the point where it reaches a critical value for the maximum current through that resistance, the current, not encountering sufficient resistance, begins to increase rapidly, generating heat that damages the circuit and causes it to break. Current, potential difference, and resistance in a circuit are interdependent and must always be properly balanced to ensure that critical points are not exceeded for the electrical circuit and that circuit is not damaged. According to Ohm's law, voltage is the amount of current flowing through 2 points of a conductor multiplied by its resistance. V equals I times R. Resistance is the voltage across the 2 points of the conductor divided by current flowing through it. R equals V over I.